Hi, everyone. I'm Sean Chen, currently a faculty member of a Prestige Department of Poultry Science at NC State. Today, I will present the research project that I conducted at University of Georgia when I was working as a postdoc for Dr. Woo Kun Kim. In this project, we aim to evaluate the effect of guanidinoacetic acid on growth performance and bone development in broilers. GAA is a precursor of creatine. Creatine has been used as a health and fitness supplementation for humans for a long time. It plays an essential role in energy metabolism through the creatine and phosphocreatine system. The creatine and phosphocreatine system does not occur in all cells. Instead, it's confined to the cells that have a high but variable energy demand, such as skeletal muscle, heart, brain, sperm, and immune cells. The animal's demand for creatine can be supplied either directly from animal protein in the diet, such as fish or animal byproduct meal, or by endogenous synthesis in a two-step reaction. In brief, the first step occurs mainly in the kidney and the pancreas. L-arginine reacts with the glycine to form L-ornithine and GAA. The second reaction takes place in the liver. GAA is methylated at amidino group to form creatine. However, it is estimated that only 66% of a daily creatine requirement can be synthesized by animal, while the remainder is required from the diet. Even though creatine could be supplied by providing meat or fish meal, it is not heat resistant during the rendering, therefore may be insufficient in the conventional diet. In a vegetarian diet, the creatine level is even lower. GAA as the precursor of a creatine could be a potential feed additive to replace creatine with many advantages. First, GAA is more stable and less expensive. Second, as we learned that arginine is a precursor of a GAA, providing GAA directly to the animal could spare arginine and leave arginine available for other processes. Many research have shown dietary supplementation of GAA could increase creatine concentration in tissue. For the performance, there are controversial results on the effect of GAA in body weight gain. However, an extensive number of research trials have proven that feeding GAA improve feed conversion ratio and breast yield in broilers. In vitro studies also indicate the improvements in muscle development by GAA, but very limited data are available in poultry to show the similar effect in vivo. At last, previous research also suggests GAA has a beneficial effects on bone health. In the current study, we're aiming to evaluate the dietary supplementation of GAA on growth performance, body composition, bone strength, and gait score in broilers, especially during the heavy birth production. According to the previous research, we hypothesize first, GAA could improve the performance and feed efficiency. Second, GAA could improve the bone health, especially during heavy birth production, which may reduce the incidence of laminates. In the current study, total 648 day-old male COP 500 birds were used. They were randomly assigned to 3 dietary treatments with 12 replicates and 18 birds in each pen. The 3 dietary treatments were control diet without GAA, 0.06% GAA, and 0.012% GAA. The birds were raised on floor pens, and the treatment diets were formulated to meet the requirement of COP 500. The dietary treatment were provided throughout the whole trial. All the birds were raised until 56 days. At the inclusion of each feeding phase, the body weight, feed intake were recorded. The FCR was calculated. At day 54, all the birds were subject to gait scoring using 0 to 2 scale with 2 as severe impairment. At the end of the trial, which is the 56th day, 1 bird per pen were used for leg and breast muscle creatine concentration test. The TBS were also collected for the bone breaking strength and bone ash analysis. And the whole birds was used for whole body composition analysis using DEXA. All the data were analyzed using SAS software by Vanway and Nova. The multiple range test was used for mean separation. P-value was accepted at 0.05. For the result, for the growth performance, the only difference was seen at day 42, where 0.12% GAA treatment had the highest body weight gain, which is 53 grams higher than the control group. For the accumulative FCR, there's no difference. However, numerically, 0.12% GAA consistently increased the FCR by 2, 3, or 4 points during different phases. For the creatine concentration in the tissues, no difference was found in leg tissue. However, supplementation of GAA in the diet significantly increased the creatine concentration in breast tissue. While comparing the breast and leg tissue, breast tissue has a higher creatine concentration than the leg tissue. For the whole body composition, there's a significant reduction in the whole body fat percentage. At the same time, a significant improvement in lean percent when supplementing the birds with 0.12% GAA in the diet. For the bone quality, from both DEXA scanning and bone ash analysis, we did not observe any improvement in the bone health. However, from the gait score, adding 0.06% of GAA in the diet this treatment has the highest 0 score birds and the lowest 1 score birds, which means this supplementation reduced the laminase in the birds. In summary, first, adding 0.06% or 0.12% GAA showed a positive effect on the growth performance. Second, adding 0.06% or 0.12% GAA increased creatine concentration in the breast muscle. However, the limited effect in the leg muscle. Third, adding 0.12% GAA improved muscle development, evidenced by the increase of a lean percentage in the birds. At the last, 0.06% GAA in the diet could alleviate the laminase in the birds from the current study. Well, thanks for your time to listen my presentation today. Please let me know if you have any questions or comments. Thank you.